Now, in this lecture, we will discuss the instruction set of 8085. Now, what is instruction? An instruction is a binary pattern designed inside a microprocessor to perform a specific function. Now, such instruction group of instructions are called as a instruction set. Now, in 8085, total 246 instructions are there. Now, these instructions are represented by 8-bit binary value, and this is called as a opcode or instruction byte. Now we will see the classifications of instruction set based on the functionality. So there are five different types of instruction sets are there. One is data transfer instruction, arithmetic instructions, logical instructions, branching instructions, and control instructions. Now what are these and what are the examples we will see now. Now data transfer group. Instructions which are used to transfer data from one register to another register or from memory to the register or register to the memory. These are called the data transfer uh, instructions. Now here you can see the examples: move, immediate, LXI, LDA, STA. Now what are all these? I will explain in detail explanation in the next forward lectures. Now this is the example for one. Now here I have shown the mnemonic. Now here this is the instruction format. So move A comma B means what? B register content we are moving into the A value. Now LDA 2000 means what? Here 2000 is the address location. Now in this address location, whatever the data is there, that data we are moving into the accumulator. Load accumulator with location means what? Address location. In this location, whatever the data is there, that data we are moving into the accumulator. Now next one, while executing these instructions, so flag registers will not affect. So flag register will not affect. Now coming to the arithmetic group. So it performs the arithmetic operations, addition, subtraction, increment, decrement of the content of the register or memory. Now here you can see the add, sub. This is for addition, subtraction, incrementing in the register value. DAD is nothing but you can add the 16-bit register pair. Now decrementing. So here I will show one example. Add B means what? B content you are adding with the accumulator. In the architecture, we have seen that. So ALU, for ALU, one of the operand is going from the accumulator and one more operand we are applying from the temp register. So here accumulator, one of the operand must be in the accumulator. So whenever we are using the add or any logical operations we are doing, so default, all those operations are done with the accumulator. That's why here accumulator is not shown. So add B means what? B content we are adding with the accumulator. Again, result will be stored into the accumulator. Now this is one of the example. Remaining all in detail, I will explain. Logical group. It performs the logical operations such as and, or, compare, rotate, etc. Now examples are what? ANA means what? Anding ANA and register if I specify, then register B content ANDing with the register A, and a result will be stored in the register A. Now these are the examples I will explain in detail. Now when we are executing these instructions, all the flag registers will affect. So all the flags will affect for the arithmetic and logical operations. Now coming to the branch control group. So the branch instructions alert normal function. It will change the sequence of the program. Actually, branch instructions will change the sequence of the program. If this is your program, so microprocessor will execute the instructions one by one sequentially. So whenever the branch instructions are used, for example, jump some address location is used, immediately after executing, this will jump to the address location. Means what? Sequence of the program will changed by the branch instruction. Now these jumping is, now here I have used the jump instruction. This is the unconditional. Means what? Without checking any condition, simply it will jump to the address location. And fewer conditional instructions are there. It will check now JC, JZ. It will check the carry flag. If the carry flag is set or reset, depending upon that, it will jump. And it will, depending upon the zero flag, it will jump. Now these are the conditional jump instructions. Now coming to the call instruction, when we are using the subroutine, So in between here, this is program in between call and some address location if you use, then after executing this, it will go to that address location, whatever the program is written over here, it will execute, and after executing the written instruction, again, it will come back to the main program. So this is the instruction used for the subroutine. So these will change the flow of the flow of the program. Now coming to the machine control, now here except auxiliary carry, remaining all flags will affect. Now these instructions are mainly used to control the microprocessor operations. Now example, if you see halt, no operation, disable interrupt, enable interrupt, rim and sim. Rim and sim are the instructions used to read the serial data and send the serial data outside. Now in the architecture, you have seen the serial IO control. For that we have the SID and SOD. So sending outside and receiving inside. Now for this to read the serial data and to send the serial data out, so we need to use this rim and sim instructions. Now this is about the classification based on the functionality. So now coming to the classification based on the format or length of the instruction. Now here three types are there. One is a 1 byte instruction, 2 byte instruction, and 3 byte instruction. So 1 byte instruction means now the complete instruction we can write it in fields. Now 1 byte instruction is having only one field, 2 byte instructions are having the two fields, and 3 byte instructions are having the three fields. So in the 1 byte instruction, it is having only the opcode. So 1 byte instruction which is having only opcode, those are all instructions comes under 1 byte instruction. Now 2 byte instruction means the first byte is the opcode and second byte is the 8-bit data which we are specifying in the instruction. Now 3 byte means what? The first byte is the opcode and second byte is the 8-bit data, lower order data, and next third one is also 8-bit operand. Now data we call it as here operand. So here also instead of saying data we have to say operand. So this is a technical word. So operand. This is the lower order, this is the higher order. Now we will see the few examples for these three types. Now here if you see move a comma b, in this instruction we are not specifying any data, only two registers are used. So for this the opcode is 78, only opcode is there, only 1 byte opcode is mentioned here, and it occupies only one memory location. Now here if you see the add m means what? Memory location content we are adding with the accumulator. So here also only register is specified, no data is specified within the instruction. That's why it is also called as the 1 byte instruction. Now coming to the 2 byte instruction. 2 byte instruction is what? First byte is the opcode, second byte is the operand which we specified in the instruction. Now if you see the move immediate a comma 7f means what? Here within the instruction we specified the 8-bit data. This is the 8-bit data or operand. Now here move immediate a comma data, for that opcode is 3e, and whatever the data we specified here, that we need to write the as a next byte. So these are the 2 bytes. Uh, this is the 2 bytes occupying the memory locations for the move immediate a comma 7f. So that's why it is a 2 byte instruction. Now if you see the ADI, what we are doing here, accumulator content directly we are adding with the 0FH. Now whatever the data is there in the accumulator, that data we are adding with the data which we specified in the instruction itself. So now wherever the data we are specifying within the instruction, there you need to put I. I means what? Immediate. Within the instruction only you are giving the data, immediate. So this is the example. Now here for ADI data, for that what is the opcode? C6 is the opcode. And whatever the data we are specifying, that also we need to write in the next location. So it is also occupying the two memory locations. That's why it is a 2 byte instruction. Now coming to the 3 byte. Now along with the mnemonic, if you are specifying the 16-bit address or 16-bit data, then that is called the 3 byte instruction. Now it will occupy, now jump address location, that for that opcode is C3. And how we will know this opcode? You no need to buy hard anything. So we provide the opcode sheet to you. By seeing the opcode sheet, you have to write the opcodes. Now, after writing the opcode, what you need to write, whatever the data we are specifying, first you have to take the lower order address. Now, if you are taking 9050 means this is the lower order address and this is the higher order address. So first you have to specify the lower order address, and after that you have to specify the higher order address. Now it is occupying the three memory locations. So it is having the three fields. That's why it is what? 3-byte instruction. Similarly, LDA address location. LDA address location means what? In this address location, whatever the data is there, now for example, if I take 12H, that 12H we are moving into the accumulator. So now here we have mentioned the 16-bit address. So LDA address is the, it is having the opcode of 3A, and whatever the address we are specifying, that we need to write in the next two locations. That is lower order first you have to write, and the next higher order you have to write. So it is occupying the three memory locations. It is having the three fields. That's why it is what? 3-byte instruction. Now simply how to remember this? If you are not mentioning any data within the instruction, all those instructions are comes under 1-byte instruction. Now, if you are specifying any 8-bit data, all those instructions are comes under 2-byte. If you are specifying any 16-bit data within the instruction, then all those instructions are comes under 3-byte instruction. Now, this is very important. Why? Because while writing the program, you have to um, uh, while writing the program, you have to give the address location. So reserve the address location. For that time, you need to know how many byte of instruction. So this is about the classifications of instructions. In the next class, I will explain the data transfer, arithmetic and logical branching and control instructions in detail.